Intro to deep learning. We know that our world is one of big data. However, big data is not smart data. Even though the global data volume is estimated to be 40 exabits by 2020. The data contributing factors in data growth are scientific, governmental, corporate, and personal data stores. The issue is that big data requires deep learning. Our older algorithms are not keeping up with the growth in big data, and we need new data science methods to extract understanding from the data. Within the broader computer science context, there is the computer science discipline. Within that, the field of artificial intelligence. Within that, machine learning. Within that, neural nets, and within that, deep learning. Really, a lot of AI budget and research focus at the moment is on deep learning. Deep learning, what it is, conceptually, deep learning is a software program that can identify what something is. Technically, deep learning is a class of machine learning algorithms in the form of a neural network that uses a cascade of layers or tiers of processing units to extract features from data and make predictive guesses about new data. Deep learning and AI is an interesting point in that the system itself is dumb, it's mechanical. The system learns, so to speak, with big data, having lots of input examples, and making trial and error guesses to adjust weights and biases to identify key features. The system creates a predictive method of identifying new examples. The AI argument is that big enough data is what makes a difference. Finally, having big enough data is what makes a difference. We're running fairly simple, straightforward algorithms over very large data sets, and this is what helps us have results. The pictures at the bottom indicate the 3 key steps. Number 1 is the input being very big data, many examples. Step 2 is the method of using trial and error guesses to adjust computation graph node weights. And number 3, such that the output system correctly identifies new examples. For example, we feed a deep learning system a photo and we want it to identify what something is. It creates an image recognition system that determines which features are relevant at increasingly higher levels of abstraction and correctly identifies new examples. There are 2 types of deep learning, supervised and unsupervised. Supervised, where we classify labeled data, and unsupervised, where the system finds patterns in unlabeled data. We have created the amazing labeled data resource of YouTube cat videos, in the sense that there are over about 100 million cat videos on YouTube. That means there's a video of cats and it's labeled with meta text called cat. And so this allows us to run deep learning algorithms over YouTube. And indeed, this is exactly how Google had some early results in 2012 of computers teaching themselves to recognize faces of humans and cats. The current news in May of 2017 was that Google's deep learning algorithms reached a 95% threshold of machines being indistinguishable from humans at recognizing objects. There are 2 main kinds of deep learning nets. One is convolutional neural nets, used for image recognition. They convolve, that is, they roll up to higher levels of abstraction in feature set recognition. And recurrent neural nets, used for speech, text, and audio recognition. RNNs recur, that is, iterate over sequential inputs with a memory function, often using an LSTM, a long short-term memory function, which remembers which sequences might be salient and avoids gradient vanishing, avoids hitting limits in its analysis. There are 3 key technical principles to deep learning. First of all is to map your problem into a sigmoid function or a logistic regression. So no matter how complicated the inputs are, you map them all onto an equation that will deliver some sort of answer on an S-curve between 0 and 1, or -1 and 1. And that means this S-curve gives you the ability to optimize using all of the tools of calculus that are at our disposal. Also, having answers that can be neatly read on a basis of 0 to 1 gives computing algorithms an easier task of identifying samples as to yes or no, this is the kind of sample we're looking for. The second principle is a perceptron structure. So this is a core computational unit, an input processing output unit that is used in the network with the levers of weights and biases to adjust what happens with that computing node. But the perceptrons are purely modular, Lego-like bricks that we just build up into millions or billions of them in different tiers of computation across the system, where the dumb system learns by adjusting the parameters and checking against the outcome. The third key technical principle of deep learning is the loss function, where we use calculus to reduce combinatoric dimensionality, particularly a loss function to optimize the efficiency of the solution. They're called deep learning nets, but how do they actually learn? The neural net actually learns, or we say that in the sense that it's a structural system based on cascading layers of neurons with variable parameters of weights and biases. The system varies the weights and biases, which are a component of each computing node, to see if a better outcome may be obtained per small tweaks. We repeat this method until the net correctly classifies the data. You can quickly see the problem that might arise, which is that it's inefficient to test the combinatorial explosion of all possible parameter variations. So the solution proposed in a 1986 paper is backpropagation. And backpropagation continues to be a key research focus. We backpropagate the errors and gradient descent through the network as an optimization method to adjust and calculate the error contribution of each particular neuron or node after a batch of data is processed. Thank you.